Good morning, students. Welcome to video lecture on electromagnetic waves and transmission lines. Subject code U18EC 403. Topic field components and propagation characteristics in parallel plane waveguide. Lecture level outcome. After completion of this lecture, the student will be able to apply the concept of parallel plane waveguides to solve gate problems. A parallel plane waveguide is the simplest waveguide consisting of two parallel plates made from two conducting plates. Between these plates, there is a medium characterized by permittivity and permeability. It is a parallel plane waveguide, plane 1, plane 2. These two planes are separated by distance a along the x-axis. Assume the electromagnetic wave traveling along z-axis. In rectangular waveguide, the distance along x is a and the distance along y is b. They are finite. In case of parallel plane waveguide, the distance along x, that is a, is finite, and the distance along y, b, is infinite. That is the difference between parallel plane waveguide and rectangular waveguide. That is b equal to infinity means the waveguide is infinitely extended along y-axis. Dou by dou I of field components is equal to 0. These two modifications are to be done in rectangular waveguide. By substituting b equal to infinity in propagation characteristics of rectangular waveguide, we get the propagation characteristics of parallel plane waveguide. By substituting dou by dou I of something equal to 0 in the field components of rectangular waveguide, we get the field components for parallel plane waveguide. The field components in parallel plane waveguides are rectangular waveguide is given by equations 1, 2, 3, and 4. In the previous lecture, we have gone through the field components in a rectangular waveguide and also the trick how to write the field components in rectangular waveguide. As we know, the parallel plane waveguide is infinitely extended along y-axis. Dou by dou y is equal to 0. By making dou by dou y equal to 0 in a rectangular waveguide, we'll get the field components in parallel plane waveguide. The propagation characteristics in parallel plane waveguide. Substitute b equal to infinity in the propagation characteristics of rectangular waveguide. We get the propagation characteristics for parallel plane waveguide. Fc is equal to Vc by 2 m by a square plus n by b square power 1 by 2. If the value of b is equal to infinity, we get Vc by 2 m by a as the cutoff frequency for parallel plane waveguide, and the cutoff wavelength is equal to 2 by m by a square n by b square. By substituting b equal to infinity, we get the cutoff wavelength for parallel plane waveguide is 2a by m. Here it is square root. There is no difference in beta, lambda z relation, phase velocity, group velocity, and their product, wave impedance eta te, eta tm, and their product eta te and eta tm is equal to eta square. Refer to the sample problem and its solution on parallel plane waveguide. Thank you. We will meet with the next lecture.